Hello, everyone, and thank you for joining us today. It's my pleasure to introduce Alex Thomas to present Building Gen AI Apps with the LangChain Neo4j package. Over to you, Alex.
Hi, everyone. Good afternoon. Welcome to the Building GenAI Apps with the LangChain Neo4j package workshop. And without further ado, let's get started. Before I start, let me take you through what will be covered today. So this talk is going to be a hands-on workshop covering the LangChain Neo4j Python package. I'm going to first take you through a few slides explaining what LangChain is. I'll give you an overview of the LangChain Neo4j package. Then we'll dig into each of the core components of the package. I'll give you an explanation of each component, then run through a Jupyter notebook showcasing the components. For these demos, I'll be using the recommendations dataset, which is one of Neo4j's example datasets, and I'll be using this for all examples. This is a dataset containing information about movies, actors, directors, and reviews. And you can download the dataset at GitHub. I'll also include a link to the GitHub page of the code I'll be running through here in case you want to download it at a later date and run it yourself. You will need an OpenAI key for this, however. And don't worry about noting down any of these links. I have a final slide with them all on. I also want to quickly mention what won't be covered today. Core GenAI concepts, in particular, such as LLMs, vectors, RAG, GraphRag, prompting, etc., won't be covered. I'm assuming basic familiarity with these concepts throughout this talk. If you aren't familiar with them, however, we have a great GenAI fundamentals course on our Graph Academy website, which can help you get up to speed. Okay, let's get started. So what is LangChain? Nowadays, LangChain is a company which supports an ecosystem of libraries for building applications using LLMs. The original LangChain library was probably the first big library for developing GenAI apps, which came out shortly after LLMs really took off a few years ago. The modern LangChain libraries come in both Python and JavaScript versions, but there isn't exactly a one-to-one correspondence between the two languages. There might be slightly more features in the Python versions. Don't quote me on that, though. These libraries, they include support for most of the major LLM providers, so OpenAI, Anthropic, Google, etc. And these libraries can be grouped into several categories. So there are the core LangChain libraries. These are maintained primarily by the LangChain organization. These include a lot of the key classes which you'll need to use in any LangChain GenAI project, as well as sort of core abstractions that are used by almost all of the other libraries. So for example, the LangChain core library includes things like prompt classes, base LLM classes, base vector store classes that are used kind of throughout the other libraries. Then there are the LangChain integrations. These are typically maintained jointly by LangChain and another company. So these include things like database integrations, which allow LangChain to be used with certain databases, for example, LangChain Neo4j, and LLM integrations. So things like LangChain OpenAI, which adds support for OpenAI models. But they're not limited to these two types. There are integrations for all manner of things. Finally, there are also tools which are maintained by LangChain, things like LangChain for GenAI app observability, Langsmith, I should have said that, and LangServe for deploying GenAI apps. And typically when you build a GenAI app using LangChain, you'll be using one or more of the core libraries along with some integrations and tools. So what about LangChain Neo4j? It's one of the LangChain integrations I mentioned on the previous slide. It's jointly developed by LangChain and Neo4j and is Python only for now. Its purpose, as you probably guess, is to allow developers creating apps with LangChain to use Neo4j databases in their apps. And it has some cool features. At the more basic end, it includes a interface for interacting with Neo4j databases. So for doing things like executing Cypher queries against the database. It has a vector store class, allowing for interactions with Neo4j vector indexes. It has a natural language to Cypher question answering class. And a class for storing chats with LLMs in a structured way in a Neo4j database. And it's available on PyPy and on GitHub. There's also docs on the LangChain site, and we also have a kind of introductory page on the Neo4j site to it. Cool. So now I'm going to go through each of the core features of the LangChain Neo4j package one by one, and I'm going to demo them for you. So first up, we have the Neo4j graph class. This is a basic interface for interacting with a Neo4j database, the one I mentioned on the previous slide. And with this class, we can do things like execute Cypher queries against a database, and return the results. We can retrieve the schema of a database, and we can create nodes and relationships from documents and upload them to a database. This class can also be used as an input to basically all of the other classes in the package. So if you wanted to sort of set up a connection to a database in one place and then just sort of pass it around your application, you can do it using this class. Right. With that out of the way, let's jump into the first demo. So I'm going to stop sharing my screen now, and then I'm going to share a Jupyter notebook with you. Here we go. You all should be seeing a Jupyter notebook now. So I'm going to run through a demo of the Neo4j graph class. So feel free to ignore this first cell I'm going to run. This is just for setting up some of the visualization stuff that I'm going to be using in the rest of the notebook. Okay. So to use the Neo4j graph class, we first need to set up the Neo4j graph object. We need to provide it with the database connection details. So we can provide it with the URL here, with a username for our database, a password, and a database. Once we have those, we run this cell, and we should be connected. We can then use this class to query the database. So here, like I mentioned a few slides ago, we're using a database containing movie information. So this database has like movies, actors, stuff like that in it. So we're just going to query some movies here, see what we get. So here we go. Using this class, we've got some information about Toy Story, plot, some information about Jumanji, and a few other movies here. So we can also retrieve the database schema just by using the get schema property. So we can see a little bit more about our database at a high level. So we have, like I said, movie nodes, director nodes, person nodes. We have some relationships like rated, acted in, and you can see how they relate to the nodes. So we have movies that are in genres, directors that have acted in movies, directors that have directed movies. We could get this information just using the get schema property. And we can add additional nodes and relationships to this database. So here I'm going to add a little bit of information about Timothée Chalamet. So we want a new actor node. We've got Timothy's name, his date of birth. We're going to add in some information about the movie Dune as well. So we've got the title of the movie, when it was released, and we have an acted-in relationship with Tim's role, Paul Atreides. So we're going to add this to the database now using the add graph documents method. And we can query the database again, and we can sort of see matching on Timothy and matching on June. We've got some results here, so we can see that it's been added to the database. And we can visualize this now. So I'm going to use a tool to visualize the database here. So we can see our Timothy Chalamet node with our born in and our name, our acted in relationship, and our movie node with the release date. So this is a visualization of the database here. Once you're done with the Neo4j graph object, it's always a good idea to close it as well, so that you don't leave any kind of dangling connections. Okay, back to the slides. So next up, we have the Neo4j vector class. This is a class for interacting with vector indexes in Neo4j. We can use this class to create new vector indexes and populate them with vectors. We can add vectors to existing indexes using this class. And we can query vector indexes and return nodes containing text similar to our query from the database. So we can perform vector similarity search using this class. So we can use this class as a retriever in a RAG application if you wanted to. This class also supports full text indexes from Neo4j. So these indexes operate more on a kind of text similarity metric than a semantic similarity. So are your queries more similar to other text in the database in terms of structure rather than in terms of meaning? So we can use full text indexes with this class, and we can combine them with our classic vector indexes, and this means we can do hybrid search using this class. Okay, back to the notebooks. Okay, once again, I'm just going to run this cell at the top. This is just setting up my visualization tools again. Okay, so to use the Neo4j vector class, we need to provide a database connection. We need to provide some details of that. So there's sort of two ways we can do it with this class. We can provide the details directly to the class, like we did in with the Neo4j graph class, or like I think I mentioned already a few slides ago, we can set up our connection using the Neo4j graph object, and then we can just pass that to the class. So that's what we're going to do here. So for this example, this notebook, we already have a vector index set up on the movie nodes. We have it set up on the plots of the movies. And each movie node contains an embeddings property, which contains the embedding for that plot. So I'm just going to show the index we have here. You can see we have an index of movie plots set up on the movie nodes, and the embedding property contains the embedding. So to use our Neo4j vector object, we need to provide some information to it beyond just the database connection. So we need an embeddings model. So here we're going to be using the OpenAI embeddings model, the text embedding adder O2 model, because that's what the vector index was set up using. We need the name of our vector index. So like I said, like I've shown here, this movie plots. We need the type of node that our vector index was created for, so movie. The property containing the embeddings, the embedding, and the text property used to create the embedding. So this was plot for this. And of course, yes, our database connection details that we're going to use the Neo4j graph class for here. So we provide this all to our Neo4j vector class using the from existing index method. This should set up. Cool. Now we can perform a similarity search using our class, and we can retrieve movie nodes which have plots similar to our query. So we're going to query the vector index for movies about a sentient cowboy doll. I'm going to bring back movies which have plots similar to this query here. So no prizes for guessing what movie I was thinking of with this query, but let's just check that we get the right movie back. And we do, we get Toy Story, and we get a plot here. A cowboy doll is profoundly threatened, blah, 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 blah. Okay. We can also use our Neo4j vector class to create new vector indexes and add vectors to existing indexes. So we're going to create a new index using some documents about GenAI libraries. And to do this, we're going to provide off a from documents method with some documents, of course. Once again, an embeddings model, some database connection details, a name for a vector index. So we're going to call it libraries here, and the type of node the vector index will be created for. So we're dealing with GenAI libraries. So I've just called this node type here, node label library. So these are our two documents. So we have like a sentence about the LangChain library, and then a sentence about the LangGraph library. So we're going to, it's quite a small index with only a few documents, but this should illustrate the example quite well. On here, I'm just showing as well, like I said, you can use the Neo4j graph class to provide database details, or you can provide them directly. Here, I just thought I'd show us providing them directly to the class. Okay, let's run this. Let's check if our vector index has been created. Looks like it has. We have our libraries index on our libraries nodes, which have an embedding property. Now let's see if our documents have been added to the database with our embeddings attached. Here we go. They have. So we have our two documents here about LangChain and LangGraph. And if we go to data here, we can see each of them has an embedding attached. Okay, cool. Now let's search our index. So, like I said, we've only got two documents here, so we're just going to return the single document that matches our query the best. So we're going to ask, what is LangChain? And hopefully we will get the LangChain document back. And we do. LangChain is a framework to build with LLMs by chaining interoperable components. Cool. And once again, we want to make sure we close our Neo4j graph class. All right, back to the slides. Next up, we have the GraphCypher question answering chain. This is a class for interacting with a Neo4j database in natural language, so no Cypher required. This class uses an LLM and the schema of the database that we saw a few slides ago to convert a user's question into a Cypher query. The query is then executed against the database, and the result is sent along this result. So the results of the query is sent along with the user's original query back to the LLM, or you can use a second LLM if you wish. The LLM uses this information, so the original query and the result from the database, to answer the user's original query. Okay, let's see it in action. Okay. So as always, we need to provide some database connection details to use this class. So we're going to use our Neo4j graph class, yes again. And then in order to use the GraphCypherQAChain, we want to provide it with at least one LLM and our connection details. It's important to realize as well that the GraphCypherQAChain can potentially generate any cipher. So the cipher could be dangerous. It could delete data in your database. It could do, all sorts of nasty stuff if your query is nasty enough, basically. So when using this class, we ask users to set the allow dangerous request to true, just so they're aware that potentially damage can be done if the chain generates cipher, which is a little bit dodgy. We're also going to return the intermediate steps here with this class, just so that this will allow us to see the cipher that has been generated and the result of using that cipher against the database. If you set this to false, you just get the final result back from the chain. You just get just a natural language text. And we're going to be using the GPT-5 Nano from OpenAI LLM for this. Okay, let's set this up. All right, let's ask the LLM let's ask the chain a question. So we're going to ask the question about our database. When was the movie Heat released? It does take a little while, this class, because it's using at least 2 LLM calls. So we can see here in our results, we've got the original query. When was the movie Heat released? In our intermediate steps, we have the Cypher that was generated with the first LLM call. So our LLM here has generated quite a good little Cypher query. It's matching it on a movie with the title Heat, and it's returning the release date. In the context key here, we have the result of using that Cypher query against the database. So we have the m.released, and we can see it's released in 1995. So this context, along with our original query, is what's sent back to the LLM in the second LLM call. And then the LLM uses that to provide us with our final result. So Heat was released on December 15th, 1995. Somebody here could tell me if that's correct, but that's the data. That's the answer we have in the database. So it's correct for the database at least. Instead of returning the final result as well, we can actually just skip the final LLM call if we want and just return the result of running the LLM generated query against the database. So we don't have to have that second LLM call. So if we run this again with using it with run.direct true, we should just see the result from the running that query against the database. So you can see here we just get back released 1995, which was in our context key in the previous call. Like I said, we can also provide separate LLMs for Cypher generation and question answering steps. So this is really useful if you have like a particularly good, like text to Cypher LLM or something like that. You can use that for generating the Cypher, and then you can just use your standard LLM for like generating the final answer. So that's what we're going to do here. We're going to use a slightly more powerful LLM, the GPT-5 Mini. I'm going to ask it a slightly more difficult question. So who directed Heat? Okay, so here we go. We could query a little bit more complicated this time. We have a relationship in it, but it looks correct. We're getting the right director name out. We can see Michael Mann directed the movie Heat. So this is using 2 different LLMs here. Okay, back to the slides for the final components. Okay, finally, so we have the Neo4j chat message history class. This is quite a simple class. It allows you to store your chat message history with an LLM in a Neo4j database in a structured way. And this can also be used with other LangChain classes, such as the GraphCypherQAChain we saw in the previous example. So you can store your message history with that. So back to the example. So once again, we need to provide our chat message history class with some connection details. So we'll use the Neo4j graph class again. When we set up the chat message history class, we also need to provide it with a session ID. So this is what is used to uniquely identify a conversation. So if you use a session ID and then you come back and rerun, if you have a session ID already in the database and you have a chat with an LLM, and you reuse the session ID another time, then the class will assume it's part of the same conversation. So change this when you want a new conversation, basically. We can imitate the conversation between a user and an LLM using this class. So we're adding messages here to the database, hi from a user and what's up from an LLM. We can see here these messages in the database. So you can sort of see here, we have our first message, we're all human, hi. This points to the next message from the AI, what's up? And then we have our session node with our session ID that points to the last message in the chain. So this is the node that basically helps us uniquely identify those conversations. We can delete the conversation history just using the clear method. And if we provide the delete session node, this will delete the session node as well. So we can see here, querying our database, this conversation above has gone. And like I said, we can use this class to, along with other classes in LangChain, to store conversation history. So we're going to do that here with our GraphCypherQAChain. And we're going to provide that once again with an LLM, and we're going to wrap it using this runnable with message history, which allows us to use our chat message history with this class. So when we chat with this class this time, once again, we provide it with a query. So we're going to ask it when heat was released again. And we also need to provide it with a session ID, like I was mentioning, so that it can uniquely identify that conversation. So let's invoke that there. Okay, once again, I have our correct result. Let's see it in the database. Once again, we have our first message from our query to the chain. So when was the movie Heat released? We can see our response from the AI. Heat was released on December 15th, 1925. And our session node again for this conversation with the LLM using our GraphCypherQAChain class. Okay, so back to the slides one final time. Yeah, that's it. Thank you for listening. I hope that was helpful. I have on the screen here a list of all of the links from this talk. I don't know. It might be easy maybe if I paste them in the chat. I've included here the GitHub page. If you'd like to contribute to this project, make your way over there. We're always happy to review a PR or respond to an issue. And I guess in the last 2 minutes or so, are there any questions? Doesn't look like it. Okay. Thank you very much. Yes, Maryam, I will. The link here, github.com/AlexThomas93 nodes 2025. That has all of the code in, so you can go there and just download it yourself. Esteban, yeah, I can see if you have a question. Happy to answer. Irina, I'm using Cursor. Is there a way to block write operations using a generated Cypher? Not that I'm aware of with the LangChain class, no. The GraphCypherQAChain class, I should say. Regarding the search of the vector index, do you have to specify it all the time? Yes, you need to specify the vector index whenever you use the class. It won't just pick one up. Cool. I will stop sharing there. I will post. I don't know if this is the easiest way to do. This is the list of links I just posted in the chat. But yeah, thank you so much, everyone. Thanks for your time. I hope that was useful. Goodbye.